So now in the last video, we looked at how if we have a couple of PNP bipolar junction transistors, both of their emitters to the positive supply, and then both of their bases tied together as well, but the base connected directly, there's a little jumper right there, to the collector of just one of them. And then we put resistance on that side, that will set a certain amount of current. So 5 volts with about a 0.6 volt drop gives us about 4.4 volts, and with about 4,400, it's actually 4,410 ohms of resistance, we get about 1 milliamp of current flowing through it. So since the bases are tied together though, the voltage at that point in relationship there, it will set the same amount of current through the other transistor right here, regardless of load, as long as the load doesn't limit current even further. So this time, last video we lit an LED with that. This time we're going to charge a capacitor, and you're going to see something pretty cool. When you have a set amount of current charging a capacitor, you get a voltage ramp. You get a steady rise in voltage. So with 1 milliamp, if this was able to maintain it really well, I don't think it's doing as good as we would hope. But in any case, with 1 milliamp of current charging a 1000 microfarad capacitor, you'll get 1 volt, going up 1 volt every second. So surprisingly, we are not losing the 0.6 volts at charging the capacitor, I should say. We can actually get the voltage all the way up to, it looks like 5 volts, maybe just a little bit shy. And here we have the pocket oscilloscope there. So the voltage we're going to look at is going to be in relationship to ground. That's what that's going to do. And the voltage we're going to look at is the capacitor. Also, it's the the collector of that PNP bipolar junction transistor 2N3906. Now, you can see we go up basically 5 squares right there. If I go to the positive supply, it looks like just a tad bit higher right there. So the capacitor can actually charge to the supply voltage for the most part. So I press the button there. That instantly discharges the capacitor because we're shorting it. You can see we're making a connection, direct connection to both sides. And I will release the switch. So there you can see a steady rise in voltage. I'll try to pause it. About halfway right there. So we got 1, 2, 3, 4, and then it looks like about a half of a second before we get to 5 volts right there. So it looks like this isn't quite enough capacitance to get us to 1 volt per second. So we're going to add 100 microfarad more. So with both these capacitors, make sure that gray band goes to the more negative side of the circuit. Best way to do that is just put it directly to the negative supply rail. Now we'll do the same thing. So I don't usually put this switch into that spot. Usually there's an integrated circuit there. So the breadboard's kind of rejecting it a little bit. Kind of pops out. Takes a little while for it to get used to the switch. But in case, now we got 1, 2, 3, 4, 5. Looks like we're not quite 1 volt per second, so you get 5 volts over 5 seconds, but it's a lot closer now. We aren't doing too bad, I don't think, right there.